Hello and welcome to discussion of IIT JEE Advanced Paper 2 Physics. We'll start off with the first question. First question is from SHM. The correct options are A and D. As the collision is elastic, energy is conserved, and when it comes back to the equilibrium position, its velocity is definitely u0. And then use the velocity expression, solve for the displacement, we get x is equal to root 3 by 2a, calculate the time it requires to go from the equilibrium position to the wall, which is at root 3a by 2, and you get the time to be t by 6, which is pi by 3 root m by k. So to come back to equilibrium position, it will take another pi by 3 root m by k. So the total time will be 2 pi by 3 root m by k. On the other side, it goes to a maximum compression of a, for which it takes a time t by 4, and to come back again to the equilibrium position for the second time, it takes another t by 4 seconds. So the total time would be 2 pi by 3 root m by k plus t by 2, which is pi root m by k, and when you add, you get 5 pi by 3 root m by k. The rating tricky but doable. The second question is from Gravitation. The correct options are B and D. We are dealing only with conservative fields, so definitely the energy remains constant. We use work energy theorem. Initial potential energies is minus gmm by L 2 times, and the kinetic energy is half mve squared, which is the escape velocity. The final energy, since it has to go to infinity, potential energy is also 0, and you need the minimum velocity required, so when it goes to infinity, its velocity should be 0. So both the final kinetic energy and potential energy will be equal to 0. So equating and solving, we get VE is equal to 2 root gm by L. Question number 3 is from Doppler effect. The correct options are A and B. We have the general expression for the apparent frequency in terms of the original frequency F1. In the first case, the wind blows from observer towards the source. Speed of sound is V minus W, but nonetheless, the denominator is less than the numerator, so F2 is definitely greater than F1. If wind blows from the source towards the observer, the effective speed of sound is V plus W. So again, the numerator is greater than the denominator, F2 is greater than F1. It's definitely a easy question. Question number 4 is from magnetism. The correct options are A and D. So in the region 0 less than R less than capital R, the field is only due to the hollow cylinder. The field due to the hollow cylinder is 0, but it is only due to the infinite solenoid. Hence magnetic field is non-zero. Option A is definitely correct. In the region R greater than 2R, the field due to the solenoid is 0, whereas field due to the hollow cylinder is non-zero. Again there is a net magnetic field, so option D is correct. But in the region between the two, the hollow cylinder and the solenoid, which is R less than small r less than 2R, the field is definitely due to both the hollow cylinder and the solenoid. So definitely options B and C are not true. It is a tricky problem. Question number 5 is from Electrostatics. The correct options are C and D. When you calculate for the net field at any point in the shaded region, the common region, it turns out to be rho by 3 epsilon naught vector r1 minus vector r2, where r1 and r2 are the vectors joining the center of the spheres to that particular point. And when you calculate the geometry, vector r1 minus vector r2 always turns out to be the vector joining the two centers of the spheres, which is constant in magnitude and has a unique direction. So in that region, electric field has a constant magnitude and a unique direction, making option C and D correct. It is definitely an easy problem. Question number 6 is from units and measurement. The correct option is option D. So lambda is 2d sin theta. There is no error in the measurement of lambda. So when you calculate the fractional error in D, it turns out to be cot theta delta theta. But delta theta is the absolute error and it is given to be a constant in the problem. So fractional error is proportional to cot theta. And when theta goes from 0 to 90 degrees, cot theta decreases from infinity to 0. So the fractional error decreases. It is definitely a tricky problem. Question number 7 is from modern physics, Bohr's theory. The correct options are A and C. Use the expression for angular momentum first. So nh by 2 pi is equal to 3h by 2 pi, n is equal to 3. Now use the expression for radius and we get n square by z is equal to 9 by 2, which implies z is equal to 2. And then use the formula for the wave number. And on substituting the particular values given in the problem, lambda turns out to be 9 by 5r or 9 by 32 or 1 by 3r. Okay. So out of which the first two are correct. It's definitely a easy problem. Question number 8 is from heat and thermodynamics. The correct options are A, B, C and D. We know Q is equal to mCt. Differentiate Q with respect to time and we get the corresponding expression as shown. In the graph, we always have dC by dt greater than 0 and dt by dt greater than 0. So dQ by dt is the rate of heat absorption is always greater than 0. Option D is correct. In the range 0 to 100, graph is linear. So when you solve, you get dQ by dt proportional to T, the temperature. So option A is correct. In the range 400 to 500, C is a constant. So dQ by dt is just mc into alpha, which is a constant, where alpha is dt by dt as shown. So option C is also correct. The energy supplied in the 0 to 100 range is obviously less than the energy supplied in the 400 to 500 range because C is less in 0 to 100 range compared to the 400 to 500 range. The rating for this particular problem is difficult. The next one is the paragraph type questions. Going to the first one, they want the magnitude of the normal reaction that acts on the block. The correct option is A. Use NLM. We get the normal force is mg sin theta plus mv squared by r. From the next problem, you can find out that V is 10. And when you substitute the particular values, you get normal force to be 7.5. How do you get this expression for V? Use work energy theorem. Work done by friction is equal to kinetic energy plus potential energy. And when you substitute the corresponding values, we get V square is equal to 100. So V becomes 10 meter per second. So the correct option is B. Again, an easy question. Question number 11 is from current electricity transformers. So the correct option is option A. We use the turns ratio formula. We get V2, the output, to be 40,000 volts, and we have N2 by N3 to be the given ratio there, which turns out to be 200 by 1. It's definitely a direct substitution question, an easy question. So the next question is based on the direct transmission method. For that, the correct option turns out to be B. Voltage is 4000 volts, power is 600 into 10 to the power 3 watt. So the current turns out to be 150 amperes. So the power dissipated is I square R, which turns out to be 180 kilowatt. The input is 600 kilowatt. So when you take the ratio, you get 0.3, which turns out to be 30%. It's again an easy question. Question number 13 and 14 are from magnetic field. For 13, the correct option is B. Use the fact that the torque is equal to dL by dt. dt is 1 second, and that is also equal to EQR, where E is the induced electric field. So when you calculate dl, and you can substitute dl as dm by gamma as given in the problem, and substitute the value for E, the induced electric field, as Br by 2, we get dm, that is the change in magnetic moment, to be the given value, and the effect always opposes the cause, hence delta m should be negative, which makes it option B. It is a difficult problem. The next one though, the magnitude of the induced electric field, we just have to use integral E dot dl is equal to pi r square dB by dt formula, and when you do the corresponding integration, we get E is equal to Br by 2, so the correct answer is again option B. This is an easy question. Question number 15 and 16 are from modern physics. So now we are looking at the alpha decay of 210PO84. So you find out the mass difference and subtract the mass difference from mass of the alpha particle. We get it as 0.005818, and use conservation of momentum and the kinetic energy formula to get kinetic energy as 210 by 214 into that particular difference into 932 into the power 3, and the answer is in kilo electron volts, and the answer is close to 5319 kilo electron volts, which is option A. It is definitely a difficult problem. For the next question, the correct option is C. So alpha decay of Li, m1 plus m2 is greater than m, so it is not possible. Proton emission, again m1 plus m2 is greater than m, which is not possible. And for Zn and Se to fuse, m3 plus m4 is less than m, which is not possible. So the only reaction that is possible is deuteron and alpha particle can undergo complete fusion. So it's option C. Question number 17. We start the match the following type of questions. Here they have given you different physical quantities and asked their corresponding dimensions. The correct option is C. So first use the fact that energy is half kT and get the dimensions for the Boltzmann constant. Then use the definition for coefficient of viscosity as shown, and the dimensions turns out to be m L inverse T inverse. R is for the Planck's constant, and we use the fact that H is equal to E by nu and get its dimensions. And finally, coefficient of thermal conductivity, use the standard equation and get the corresponding dimensions. It is a very easy question. Question number 18, optics. The correct option is D. If you consider E to F, ray bends towards the normal in the first refraction, so mu2 greater than mu1. Second refraction, ray bends away from the normal. So option 2 is correct. E to G can happen only if mu1 is equal to mu2. E to H, first refraction ray bends away from the normal, second refraction ray bends away from the normal again. So mu2 less than mu1, mu3 less than mu2. And for the fourth case, E to I, there is a total internal reflection happening, which can happen only if mu2 by mu1 is greater than or equal to sin 45, or mu1 is greater than mu2 root 2. It is definitely a easy question. Question number 19, again from modern physics. The correct answer is option C. So first reaction, if I take, it should correspond to a beta plus emission, keeping in mind that Z and A should be the same on both sides. The second reaction, it has to emit an alpha particle, so it's an alpha decay. So 2 corresponds to P. The third reaction, it should correspond to a proton decay, so S corresponds to 3. And the fourth reaction, we have to have another heavy nuclei coming out. So this is fission reaction. So R corresponds to 4. As far as the rating goes, it's a pretty easy question. Question number 20 from heat and thermodynamics. The correct option is C. If you take the reaction Fg, it is isothermal. Use the corresponding equations, you get the volume at G to be 32 V naught. Then find the work done from G to E. It turns out to be 31 P naught V naught. Next, take the reaction G to H and use the fact that FH reaction is adiabatic. Use the adiabatic equation and we get volume at H to be 8 V naught, and calculate the work done in the process GH and you get it to be 24 P naught V naught. Take the corresponding reaction F to H. It is an adiabatic reaction. Work done is P2V2 minus P1V1 by gamma minus 1. Substituting the appropriate values, we get the work done to be 36 P naught V naught. And finally, the reaction F to G, which is isothermal, using the corresponding standard value for work done and substituting the corresponding values, we get the work done to be 160 P naught V naught ln of 2. So S corresponds to 1. Thank you.